In today's episode,
it was wonderful. The customer was roaring.
logging helps you troubleshoot.
Plot twist, they're aware of nothing.
But what if the logging needs troubleshooting?
You need a Splunk instance to monitor Splunk, and then a Splunk instance to monitor the Splunk instance that monitors the Splunk instance.
Anyway, let's get back to the story.
Welcome to Splunk Tech Stories. A podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hi everyone, and welcome to the first 2025 episode of the Cisco Tech Stories podcast, a podcast where we interview experts on their craziest and most interesting troubleshooting stories, where we learn about new technologies and fascinating individuals. We're your hosts, Nico and Tristan, Cisco engineers in EMEA. Hello, Tristan.
Hello, Nico. Happy New Year. And what a great way to start 2025 with one more awesome guest. Let me introduce you to Devon Herron, support engineer at Splunk. Hello, Devon.
Hello, hi, my name's Devon Herron, as already suggested. I work in Splunk P1 team, so we deal with the most elevated cases within our company. These are all of the sites downs, the mission critical platforms that we have around the world. And yeah, I'm going to share some of my stories with some wonderful customers that we have.
That's great.
I first want to ask a few questions about you. So you have a team just for P1s.
Yeah.
So it's like the worst of the worst cases, you only get that.
Every single day, they're like PO level stuff, yeah.
That's nice.
So maybe it's actually a good question because you joined Cisco when Splunk was acquired by Cisco a few months ago, right? And we have in TAC, we are coming from TAC originally, and we have a different support model. So do you mind telling us a little bit how the support is done at Splunk in a few words?
Yeah, I'll try to encapsulate. Splunk's P1 support, we follow around the sun process. So we have the EMEA, and then we have APAC, and then we have EMEA, the UK, and I represent the P1 support from that region. Mm-hmm. Basically, it's an 8-hour window where we take on P1 cases to resolution. If they're elevated, we might engage specific incident commanders, or if we need to have developers introduced into the case, we'll also leverage our developers from each region.
Mm-hmm. Cool. And you said P1 support, so does it mean that you have different tiers of support?
Of course, we have P2, P3, and P4. P2, we have a premium level, which is effectively another level of P1, whereby customers have a short response time for their cases that they report, and they're treated at the highest priority, really, to try to get those fixed. And our premium customers will pay a premium for that service.
Mm-hmm. And what about P3 and P4? Is that like the basic question or minor problems? Is that correct?
Yeah, that's basic questions, minor problems, questions and answers, and we try to get them resolved as quickly as possible and move on.
Okay, cool. Thanks for the intro.
No, I was like, I have so many questions about Splunk, but go ahead with your first stories, I think.
Right. Yeah. So a couple of weeks ago, we had a customer contact us to say that the whole site was down. They had no indexing, which is our level whereby we collect the data and we store it to disk for retrieval for searches. Site down. It's a mission critical platform.
So if I understand, they have the data, but they cannot search it, right? So basically kind of useless?
That's correct. Mm-hmm. Yeah. And they're running on a SOC, so security-based platform, generating incidents and then working those incidents to resolution. So it's pretty critical that they get this working. First thing, it's a detective sort of like story. All Splunk P1 engineers are detectives effectively. We have to try to figure out what's happening in the environment, take each nugget of information and process it and try to at least make a path to resolution as quickly as possible. So we'll just go in there and we'll speak about what the customer's environment. So the customer's running a virtual environment. I'm not going to name what virtual environment, but it's an on-prem virtual platform. They have 4 indexes and in an index cluster. Their average data ingests per 24 hours is approximately 2 terabytes. So it's a medium size installation. I don't see that as a large installation because we have customers doing 65 terabyte plus.
So just
24
one
hours.
One of my NAS per day is medium. Okay.
That's right. And we have data retention policies in there as well. So but based on regulatory purposes, the customer may need to search that data for approximately 9 months or even 12 months. So imagine that. And when you're ingesting that amount, you could be into petabyte territory on some of this stuff. Yeah.
I was already picturing a 2 weeks retention policy or something like this to minimize the storage, but you're going with like 1 year. Okay.
That's right. Some of them even have longer stringent policies. So, and these are all leveraged over different technologies. This specific one is an NVMe array. And obviously, we know that with NVMe, as we reach the capacity of whatever disk there is being used, we have slower performance as it reaches over 90%. So I thought first, let's have a little check on the IOPS, see what's going on this customer's platform. We had a look at the IOPS on the actual indexes, and I could see that it appeared to be delays with accessing the storage IO waits of up to 30 seconds, which I believe is pretty ridiculous. It's huge, isn't it? Yeah, IO waits and that. Next thing, ask the customer. So obviously, this is the one that you guys are probably familiar with. Were there any changes performed to the platform? Not that we're aware of, they said.
Of course.
Not that we're aware of, yeah?
Plot twist, they're aware of nothing.
Yeah, I said, okay, so there's absolutely nothing. Oh, we do anything because there appears to be a massive IO wait delay. So we had the storage team come online, and they showed us some metrics to indicate that there was the storage was working perfectly. I saw the graphs. I'm in panic stations now. Where am I going to go? What am I going to do now? This guy's giving me some concrete evidence here to support this.
And maybe a stupid question. The storage system, is that something Splunk sells, like a hardware by Splunk?
No,
it's
the customer's own.
So you could be dealing with anything. Solution. Okay, that's your problem.
Yeah, we deal with everything. Okay. We've got to understand virtualization, networking, all the layers of any customer's platform. Firewalls, load balancers, these are all key requirements to be able to run this role. Luckily enough, I was fortunate enough to work as in the electronic trading platform industry prior to working at Splunk, and I worked in proximity-based high-frequency trading. So that's like low latency trading, and I put together networks, so I understand all the relevant components. So for me, this is easy, and I think a lot of the Splunk engineers that we have come from quite a diverse background, so they have all of this knowledge, a breadth of knowledge in the industry, and I think that's a key requirement for to be able to work in P1. Anyway, let's get back to the story.
Yes.
Yeah, let's get. So the storage team. Devon, there's nothing wrong. There's no IO waits. I said, show me some more details. Yeah, you can see it's concrete evidence here. There's no issues. I was like, oh. I said, this is from the hypervisor level. Yes, this is from the hypervisor level. I said, show me from the OS level these statistics. There was a pause for a long period of time. This guy was thinking, I had an exit, and now I've got no exit on this. So we went back to the OS, and I said, "Can I have the OS team on this call, please, in order to be able to move this case forward?" I had a member, really nice team member come on and join us. And he mentioned that there was a security patch, some security patches added recently, about 2 weeks ago. I says, what security patches were they? Oh, we upgraded RHEL from 9.3 to 9.5. I said, that's more than that's a, I said that's a
It's
significant
an OS upgrade,
upgrade.
right?
It's a big bang.
And I went back to the customer contact, the Splunk evangelist on site, and he says, Devon, ever since this patch has been implemented, the environment's not been working correctly. I was like, could you have mentioned this prior to the beginning of this discussion? Oh, we've neglected to do that. Obviously we had a good laugh in there. But the clock's ticking. Everybody, the clock's ticking. This is a suck. We need to get this thing moving. I mean, this is adrenaline-based work. So we had a look. We identified that the kernel that was introduced had a known bug. Poor performance on the Linux VMs for this specific kernel on virtual IOs.
Sounds like a good match.
So we did a soft change just on the Linux level on one of the hosts. All of a sudden, this thing connected back to the cluster manager quickly. And we had a look at the data increase, and the data increase on the chart spiked to mean that it was operational. But this case is only one side of it. This is just one tiny nugget. So we made the changes across the platform, and things appeared to be working. Next thing I identify, Devon, one of the indexes is reporting a massive problem still. It cannot connect. It's stuck in a batch adding process here. I'm like, that usually indicates that there are standalone buckets that are potentially causing problems here. A standalone bucket is basically a bucket that hasn't been replicated or no knowledge of that bucket piece of information. We have a data retention policy, and we have a policy whereby that we decide how many copies of the data there are. So we have replication policy. And if there's one there and it's not been replicated and there's no knowledge of it on the cluster manager, then that's going to create lots of issues. The cluster manager won't start correctly. It won't allow that host to connect. So we had a quick look on it, and I ran a db inspect command from one of the front ends, which is a search command that allows us to be able to check for that specific host. And generally, there's only maybe one or two of these buckets that need to be modified to allow them to work. So what we do is we just change them, move them out of the way. But lo and behold, I find 1,000. Yeah, it's just like, okay, this is no longer a manual process. We need to automate this. Yeah. So I created like a quick sed script, because we've all got a bit of bash shell scripting knowledge in the background, and I managed to identify all of the relevant buckets and just basically perform a rename on those, but categorizing them with the bucket information and adding a different incrementing tag on the end, so which we knew where it was in order to perform a cleanup exercise afterwards. Made that change, and then we restarted that specific indexer, and then had the same issue again. And then we lost the cluster manager graphical user interface. That process had stopped. So I was like, what's going on here? We have a look at the virtualization on this platform. Okay, no problem, Devon. So we have a minimum specification on Splunk for indexing, and I believe it's generally 16 cores or 24 vCPUs per indexer. I had a look on this thing, and this thing was like provisioned with 64 cores, but the hypervisor only had 32 cores, and there were multiple hosts on this thing. So we were vying for contention. So we had to then go and distribute some of the hosts to another VM hypervisor, move this to another location on the hypervisor, managed to get that sorted out. Back to it, put the cluster manager into maintenance mode, performed a restart of the cluster manager, brought it back up, then performed a rolling restart on the indexes. At this point, everything dramatically came up. It was wonderful. The customer was roaring. Hooray! No, not like that, but literally roaring. Yes! We had a look at the enterprise security manager front end, and we saw all the notable events coming in. Oh, wow, this is brilliant. At this point, everybody was cheering, and I felt like a genius.
Oh my God.
How did I do?
So I'm sure that's how the ending was, but there was 2 times before that where I'm sure the customer was like, "Hey, you told us the problem was dispatch, and we reverted it, and you still have the problem. You're lying." And you're like, "Oops, I thought I was gonna fix this." So it's like, finally, now I look good after 3 times. You did it.
Yeah,
right.
yeah, I
It's
was
like multiple
nearly
problems.
buried. Yeah. These things happen. I mean, you're constantly on the edge trying to figure things out as a detective. It's a detective sort of like situation. You've got to go back, you've got to be methodical and try to figure things out and just leverage your knowledge. And, how can I put it? Look at all the nuggets of data and use that to be able to get a trail to the end. But it was just wonderful to get the environment back up and running.
I actually have a technical question before we move on to the next. Those CPU things. So one of the typical problem we have, at least on my side of the Cisco side, is hyper-threading, because we request a certain number of cores, but like you said, sometimes they're not even dedicated, so they're oversubscribed. That's really the worst. But then even if they're dedicated, they're hyper-threaded cores, so they're not real cores. And customers are like, yeah, but I don't want to disable hyper-threading on the whole hypervisors just because your VM says this or that. So how do you handle that? Do you consider hyper-threading to be real cores, or?
I'm gonna just park that term to one side because I don't want to upset any of my wonderful customers, and I'm going to just say that I'm going to use the term vCPUs now, virtual CPUs. I'm going to say, for every hyper-threaded vCPU, for one of those, we really need 2 of these CPUs to be used. So everything needs to be a multiply factor of 2. Everything needs to be multiplied by a factor of 2.
So it's like, you can have hyper-threading, but you just put more vCPUs to compensate that.
That's correct, yeah. And sometimes these environments, we do a deploy, we do a rollout for a customer, and they do continuous data onboarding, which we want because they've got different varied use cases. They want to bring on different sorts of Cisco data, whatever it's going to be, security data, because it's a lot of our customers use it for SOC or IT infrastructure. So they've got lots of varied use cases for this, and there's some of them are generating tickets in ServiceNow using a ServiceNow plugin that we have, add-on that we have to be able to generate these tickets automatically and then run incidents based on this. So the main thing, that the crux of this is our customers, we need to steer them from the beginning to say, this environment was good at this point, but we need to have checkpoints where we have health checks, and we look at the environment and say, you've expanded the capacity, you are using more. They might increase their licensing usage and purchase more licensing from us, but we also need to help the customer understand that their infrastructure also needs to be scaled appropriately to be able to handle and manage this capacity. And I think this is a critical thing for all of us as support engineers working everywhere. We need to advise them and ensure that they have, a roadmap of what are you doing now and what are you looking to do in the future, and is your current configuration going to be able to handle that data throughput, or is going to be able to handle that load?
And I actually have a question, and it's kind of tied to what you said. when I look at a typical router from the technology that I worked in the past, I can see like, I don't know, for one day, 24 hours of data, I can see maybe 100 lines of logs. So to reach 2 terabytes per day, like you were saying, you need so many routers, so many devices. So what else are people logging with Splunk?
They're logging everything. They're logging door access for offices. They're logging everything. Till registers in supermarkets, transactional logs on online shopping. Everything is being logged. All security, any endpoint. We are the gold standard solution. I love saying that because we really are. We do it all. Splunk has got the most diverse portfolio suite. We can take any data and make a meaningful use of that, a productive, meaningful use of that. And like I said, a lot of the SOCs, they're going to be using it for Black Friday's just gone through. So all of the internet security stuff that they're using, all the endpoints, any customer interactions that are going on there. Port scanning might be going on the outside of these things. There's a lot of chatter. As you're aware, you've probably seen it. Customers also have data bursts whereby there is a significant, at some time during the day, there is a significant overwhelming use of their network infrastructure, be it firewalls, be it routers, be it switches, whatever, and generating a lot of load and generating a lot of traffic and logging that traffic. And that can have dramatic impacts on the actual Splunk, because say you've got one specific source type that you've got in there, and say you've got like a Cisco firewall, and you use that's a source type. We'd have that as a source type, just state that is one thing that we're going to be searching against, one component. So that source type could be, generating, I don't know, 500 gig in 24 hours. But say it's a really busy period of the year, that same endpoint could be generating 2 terabytes. What about the IOPS on that disk? How are you going to write that data during that time? How is that going to work in these busy periods? Do you have the correct scaling to be able to manage that creation of the hot buckets on those indexes? All of this stuff has to try to be factored in on that preliminary discussion with the customer. Is this the right solution? Again, what are you going to be doing with it? Are you a retailer? You have busy periods, peaks and troughs within your traffic? What are you doing? We have to try to figure that out. And a lot of our customers are leveraging all sorts of storage technology. Smart Store now is a big thing that our customers are using. S3, yeah.
Mm-hmm.
So a lot of our customers are using that, which I think is a great technology to use. But a lot of our customers are still using local storage, and like I said, they've got like banks of these NVMe stuck in these indexes. These single unit instances, may they be physical devices or virtual hosts. And obviously Splunk, we use all the relevant cloud platforms, Azure, etc. So were they implemented? Were they scaled correctly? Did we do the implementation? Because some of our customers will build their own clouds, and sometimes we run into issues with that because maybe the planning phase was not scaled correctly, and we have to try to figure things out. And we do have problems like that, or maybe they used the metrics of data that they originally used, and then they go ahead and onboard some additional data, which is a requirement for the business, and it wasn't actually been included within that scope of the original infrastructure install. And then all of a sudden they switch that source on, and the whole platform blows up instantly. And then there's a P1 case, Splunk's not working. Mm-hmm. And it's just in those letters. There's no further information. And that could, like I said, we have to go back in there and investigate that, try to figure out what's going on the IOPS level. Some of our customers also, we've got an aging process where our data, as it ages, like I said, there's a data retention policy. As it ages, it goes from like hot bucket to warm to cold to frozen. Now, this aging process, frozen, is basically the frozen state is where the data's basically effectively offline at that point. Customers will use NFS storage, which is the slowest network protocol that you can, but they've got an awful lot of data to try to put down this tiny little straw, and what that causes is all this backwardation of data. So that whole pipeline becomes blocked, but steadily on its way back up to the source where the forwarding the data. We have lots of issues like that. We have to try to figure all this stuff out. So anybody out there using NFS, please don't ever. Thank you. Yeah, I do not recommend it. And going forward, obviously, we're looking at various other things within Splunk. AI is a big thing now, and I'm sure that's going to be generating a significant amount of data for some of our customers.
And what are the AI features of Splunk? Actually, I have no idea. I've never used Splunk.
We're starting to implement them. We're starting to deliver suggestions on the GUI to allow you to create more efficient SPL, which is our language which we use to create searches. So I think that's the first phase, but we have a lot of stuff in the pipeline, and obviously I'm not allowed to share some of this stuff that we've had internally. I can't share that, but we're a progressive business. We want to stay in the forefront, so obviously this is a key thing.
You have another story for us? I have many other questions on Splunk, but if you have another story, let's go for it.
Okay, let's talk about another scenario. So approximately, I don't know, I think it was like 4 or 5 months ago, a customer was constantly complaining that they were having problems with their searching. They don't know what's going on. The searches is stopping, they're slowing down. What's going on? Customer's got a multi-site cluster consisting of 180 indexes over 2 sites, geographically located, in separate locations. I'm not going to say any geo proximities here, but let's keep everything above board. So I was like, what's your daily ingest? Oh, we're ingesting 50 terabytes over multiple use cases. Okay, fine. What's going on with the searches then? Had a look on the customer runs enterprise security, and they have also running some ad hoc search heads, a cluster which a search head cluster which consisted of 10 search heads. Had a look on these search heads, the 10 search heads, and I was looking at the searches. Had a look through the list. I don't want to use the term Wild West, but there were there were some of the analysts were running searches without any sort of restrictions. So their time range was over 30 days constantly, when the data that they only needed to be able to look at was just the current, a windowed search would have sufficed for 10 or 15 minutes. But they were running, we had to go in there and make a massive amount of changes to the whole. We had to put limits in for all of the changes in limits.com to prevent them from having unbounded search capabilities. Because obviously those search capabilities were putting significant stress. Imagine one search taking up, I don't know, 32 gig of RAM for one search.
when you need to deal with terabytes of data, of course, your search result will be heavy.
These search results were heavy, and then you multiply that by the amount of searches. I can't remember. It was a ridiculous amount of scheduling that they had on there. The platform was broken anyway. It was literally broken, running into the ground, because this specific ad hoc search head cluster there was no restrictions on it. And the customer was also using knowledge bundles, and these knowledge bundles, we use CSV files to be able to create lookup tables. And these lookup tables were used to be able to present things in a specific, meaningful way. So I looked at the knowledge bundle. The knowledge bundle was 4 gig. Our recommendation for these bundles are really around 500 meg. So this is basically for every single search, you're sending that payload 4 gig to each one of the search heads to then distribute down to the indexing tier to then send back the search results. That is a huge amount. So what we needed to do, this is all optimization stuff. I mean, but still comes in the realm of P1. We need to make it work in any way that we can to support the customer, and then we can leverage our Splunk on-demand services, which is a solution that we have, and then obviously we've got our professional services, which will go in there on a consultation basis and try to have a look at the whole architecture and refine things. I had a look back at the data, and one of the gentlemen was saying, "But I need this search. I need this search to last for 30 days." So we had to go through each major analyst's search details and try to rewrite each one of those searches to make them perform efficiently. This specific gentleman had about 70 of these things. I had to try to get them working within my shift. It's a significant feat. Yeah. And then I think the case rolled over for several days because all of our teams are following the sun, were performing these actions. Plus their analysts inside the company were also performing these actions. I'm just saying, so when you're setting up a Splunk environment, always ensure that you do define limits for users, because everything's, oh, this is free, I can use it. This is free, I can use it. I can do this. I could do this. And we end up in a situation whereby the platform is broken. And on the other side of that, these guys were sending these ad hoc searches, which were impacting the security side of the product, because they were also, the security side was sending searches in to those same indexes. So if these guys are unbounded, they would had a negative impact on the SOC stuff, which is even worse. So initially, I just got them to drop the ad hoc search head, pull it offline while we just have the quick investigation on it. Made sure no support engineers, none of their analysts looked at this, and then we went through, stopped all the searches and started sifting through systematically and enabling them. But it does take a lot of time. It does take a lot of time. I can see I'm not running that far on the timestamp. Have you got any questions, Nico?
Do you have people? Yes. Do you have sometimes people automating searches and things like that? Because you install Splunk and you do a few searches, like it's working great, and then people are, oh, I can use it for this or that, and they just run some automation script. They do crazy searches, like you say, unbounded, and then they just kill the performance for everyone else.
Yeah. We have a REST API whereby you can ingest, you can inject searches into the Splunk, and we have some customers using it for just these cases, and that can create. I'm going to just say those customers, obviously, as they're using REST API, they are very advanced. They know Splunk as well as our technical support engineers. These are evangelists of the product, but we do run into problems whereby that API performs differently on different releases, and their expectation for it to work the same when they upgrade, because most of our customers don't have a robust UAT testing environment, because that obviously, to be able to replicate some of these huge environments it's a difficult feat, isn't it? As you can't really replicate. You can test a scenario, but you can't replicate it under load.
I'm thinking of all the storage you would need if you need another UAT and a dev.
Yeah, exactly. I mean, just to even spin that up for like 24 hours, the test would be, significant amounts of cost. Anyway, so where was I? All right, yeah, we were talking about. I remember we were talking about REST API and injection of searches, etc. Yeah, like I said, we have customers using this functionality, and that can create big problems, but generally only between major release changes we see these issues, because we could be adding additional features and changes to our product, which our core product, the way it works fundamentally, which aren't really broadcasted or documented for customers to have knowledge of that. So just internal architectural changes and the ramifications of those can cause the problems that we've seen with P1s, etc. And then we'd be in a P1 escalation. We'd have incident commanders on, and we'd have to have the developers online to be able to at least triage and move the case forward. And that's how it would work at that point, because realistically speaking, they've got the best architectural overview because they're the ones responsible for that specific change.
I relate a lot because, I mean, in P1, you might think, okay, it's suddenly down, so something must have happened, like in your first story with the patch. But actually, a lot of P1s, you look into it, it's like, no, you're using the product wrong. Like the whole way you designed it or whatever, there's we need to do major changes to fix this. And people are like, yeah, but it just broke like, today. Yeah, but it was about to die yesterday and nearly about to die the day before. It's just coincidence it broke today, but you're just using it wrong, right? We need to do major changes. Like you need to stop doing this. You need to do this differently. So yeah, P1s can be complicated and very long sometimes.
Well, I've got my own personal take on this. So P1 classifications for Splunk that I've seen. I've worked for Splunk now, and we've only had P1 teams for 3 years or 3 years now. But before that, I was working at P2. Well, I was working P1 cases anyway before that. But regardless, I've been with Splunk coming up to 8 years next year. So I've been there a while. I've seen quite a lot of these incidents. And I think P1s can be categorized as customer plan upgrades that go wrong, known issues and bugs that customers are unaware of, bundle pushes or changes that modified on platforms without the prior knowledge to people from other geolocations working within the business. Data ingestion bursts. This is, like I said, I meant that from the endpoints over busy traffic periods that just basically saturate the hot bucket creation and the IOPS. Reduce storage performance based on the customer onboarding more data and running it really fine on the NVMEs so they don't perform correctly. So running them at 95% utilization, which I don't feel is a good thing to do.
You still have an extra 5%, right? You're safe.
And they do say this, and they customers will say this, and I will smile because obviously they're always right. But I will never respond to it. But that's the case. And then cold storage solutions like the NFS. And then we've got environmental stuff like environment issues, which I think a lot of our cases are potentially encapsulate. So that's network related changes, virtualization, team changes, OS patching, or storage team changes. And I think they cover the majority of the problems that we see on the product. And then there's obviously the ones where people who are unfamiliar with the product and make changes or implement something new which causes a problem. Then that could be a P1 status. But these things, it's a platform. Just as long as you don't break it, you should be trying and experimenting with it to try to get the best out of it. So we accept that. I mean, it's an analytic platform, isn't it? Yeah.
Just don't make searches all the time with an unbound time frame.
That's right. Don't do that. Don't use principles. Use these principles to be able to at least get the end goals.
Sorry, and that's reasonable because even back in the times of SQL database from years ago. If you're doing a search that's unbound, of course it's going to take time. Of course it's going to crash because of out of memory. So, I mean, at the end, Splunk is great, but it still rely on physical data to be transported from one place to the other. So yeah, you still have physical limit to deal with, right?
Yeah, massively.
Do you have another story for us, maybe?
We can jam it in the episode.
All right, let's talk about something else. So this is related to a smaller index cluster. This one, I think the customer was looking, the data that they were using was weather information. So large, it's a weird searches they're running to try to figure out patterns in weather. I'd never seen this use case for Splunk, but they had
in weather.
Weather, yes, weather.
Okay.
And they had like sensors, remote sensors, in multiple geolocations. These sensors, well, I didn't know they were using. Some of them were using 5G to send the data back. They're out in far locations.
So we're talking about temperature sensor, humidity sensor.
Yes,
thing,
that's
right.
That's right. That's right. And the customer was complaining about latency. Obviously, you can't really do much about latency on 5G platforms, endpoints that were in strange locations. Some of them are using sort of like satellite functions as well to send back data or receive data and send back data via, what is that, Starlink?
Oh.
Yeah, send it back via that. And what I'd identified is customer was doing performing some correlation searches, search correlations, because the data that they were trying to obtain, they were saying there was some like delays in it. They were running some correlation searches, and I identified that one geographic location that they had set up, they were only getting, the customer didn't notice, but there was a pattern whereby it was only sending bursts of data in intervals of every 1 hour. And this had been going on since the time of implementation. I pulled up the chart. I had a look through it. He said, Devon, this is a location that's not working. I pulled up a quick search, had a quick look at the index, and just showed a quick chart. And we could see that there's a massive amount of data, then nothing. Massive amount of data, then nothing.
So it's buffering the data and sending it for the whole hour, right?
That's right. And it took a while. One of the guys remote accessed onto the endpoint, and he said, for some reason, the network interface was set for power saving. The network interface was set for power saving, and they've been looking at this issue. It got escalated. This was pretty bad case. Got escalated to quite a high level, and we looked at it, and it was just simple things can create huge problems.
Yeah, and something that's totally not related to logging at all or to Splunk at all. It's something in the middle of what we're doing. Yeah, it's crazy.
Simple things.
I was wondering how the data is uploaded, because you have technologies for weather sensors like LoRaWAN, which doesn't consume a lot of battery, so it can stay always on, but it sends at a very slow pace. So you can send only very little data at a time. And then, if you have a bigger satellite uplink, then you can send more data. But then maybe for power saving, you may want to, on purpose, like you said, connect only once in a while to send the data in one burst.
To send the data.
All of that could make sense. Like, it's not necessarily a bug, right? It could be by design. You want to save battery because that sensor maybe doesn't have a power supply, right? But probably they didn't know they had that enabled. That's the problem.
I think that was the case. They wanted to have real-time stream data from this specific sensor, and it was just not delivering it. And how simple is that? This went to the highest in their whole team. It went to the highest level, and we managed to find out something simple as that.
But that raises a question in my head.
Access.
just to keep your monitoring, your logging infrastructure running, you need to monitor stuff. So if we take back the previous story with the IOPS on the storage, like your Splunk is down, but then to troubleshoot it, you need to monitor the IOPS, right? And then you would
That's
need to
correct.
notice that after installing the patch, the IOPS would be down, and somehow they should have noticed that. But then is that something Splunk can monitor? Because if it goes down, Splunk stops functioning. So
You need a
Yeah.
Splunk instance to monitor Splunk, and then a
We
Splunk
have all-
instance to monitor the Splunk instance that monitors the Splunk instance.
No. Splunk has its own metrics. So we've got an audit log and we've got a metrics log, and we CPU, all of that stuff, IOPS, we automatically write that to logs on each instance. So we can go in and identify exactly what's going on. So fortunately for us, we've got all that stuff. Customer doesn't pay for a license for that because that's our internal metrics, but we've got all that stuff there. It's built in architecturally. So it's quite a robust framework. We can do that. But generally, regarding the customer's platform and the initial scenario that we spoke about with the customer using the virtualized technology and not seeing any problems with the storage on the storage layer, it was the OS layer where the problem was anyway. And Splunk had already shown that statistically throughout all of our diagnostics files that we generate. We grab all, so you can just execute a script on any of our Splunk instances, and it packages everything up into a tarball, and then we load it into a diagnostics platform which we have called Splunk Diag, and then we can go in there and look at absolutely everything, run searches, etc., to find out what the state is, what's the health of the platform, how many searches is the customer running, what are they ingesting, license usage, everything. We get all of that data, so it allows us to be able to fix things really quickly because we've got everything.
one of the things you may want to monitor is also, so you want to monitor if the logs that come to you show a problem in the network. But if you stop receiving logs from a specific weather sensor, for example, that should also be some kind of alarm, right? Like the network's fine, but we stop receiving from that source.
That's correct.
I guess you have that.
Yeah, and we can a customer can write simple searches to be able to say, if there's no data in between from this time range, from this specific source type, it can flag an alert to any of the analysts at that point because we're reading. It's just another search. It's very simple. So the customer can set up simple searches to track any of those things.
Sounds nice. I have maybe one final question on Splunk itself. I kept for the end. So we're very familiar with Splunk as a logging infrastructure, like a monster that can digest all the logs and then give you nice interfaces to search them. Does it have other features we're not aware of? Like what about telemetry? Anything else that is outside of syslog? Features that are less popular for the networking naive people we are.
Yeah, I mean, basically, with the onset, any sort of data types, any data type, you can use things called like data model acceleration, pivot tabling to be able to derive meaningful data from any source. We can manipulate any data into any format. Some of it's quite complicated. It's being simplified now. We're trying to make things more simplified for our end users. And I don't believe that there's any real data type that we can't ingest and get any meaningful data out of the other side now. I don't think there is. So anything that you want to use it potentially for, anything that you're generating a log for from any device or any endpoint, we can do it, and if it's useful, if the data is useful for you, we can write searches against it to show you statistics on what is meaningful within that data to your business use. I think that's where I should leave that.
So the concept is just we ingest any kind of data and we produce meaningful output out of it.
That's exactly it. That's it. That is our motto. And all of our customers, majority of them are Splunk evangelists. They love the product. We're colleagues. We get on these P1s. We it might be something that's critical, but the whole fixing process is fun because everybody's a technology evangelist and we're trying to figure things out as quickly as possible. It's stressful, but there's teamwork between ourselves and the customer to get a wonderful end result, which is, platforms operational within the quickest time possible. I think that's where I should leave that specific point to.
Yeah, sounds like a great conclusion. Yeah, indeed.
All right. Is there anything else I need to say? Or we're good?
Thanks a lot for your time. It was great to have
I really appreciate it. I really appreciate it. I hope I wasn't too flamboyant, British.
You were perfect.
Thank you very much. Thank you, guys. Thank you. Take care now.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on Cisco Podcast Network and SoundCloud or in your favorite podcasting app. You can also find us on X at Cisco Tech Story without S. Thanks again for listening and speak to you next month.
There once was a chap named Devon Bright, fixing the Splunk with all his might, in the land where clouds and cables twist, keeping networks on, problems dismissed. Devon the fixer, hero of the day, solving puzzles in his own brave way, observing systems, never losing sight, guiding through the darkest night. He'd get a call when alerts would scream, dashboards dark in a customer's dream, with a tweak here and a nudge there. He'd restore the flow, like a breath of fresh air. Devon the fixer, hero of the day, solving puzzles in his own brave way, observing systems, never losing sight, guiding through the darkest night. In the tangle of logs and data streams, he'd find the flaw in the customer's dreams, a whisper, a hum, in the back-end cheer. Devon's magic always made things clear. With every nudge, the dashboards glow,